Welcome to AMS Talks. I'm your special guest host, Nadia Abboud, and today I have the pleasure of sitting down with Rick Bacon, CEO at AMS, to discuss what attendees to the 2025 AWWA Annual Conference and Exposition can expect from the self-proclaimed Swiss Army knife of water treatment. Thanks for joining me today, Rick.
You're welcome. It's great to be here.
So in addition to exhibiting your advanced water treatment and real-time monitoring solutions in Denver, AMS is going to be in the AWWA spotlight on two occasions. First, Dr. Vladimir Dortsev will be accepting the 2025 AWWA, let me get this right, Water Science and Research Best Paper Award. And then he will also be delivering a session presentation on Wednesday, June 11th. Can you talk a little bit more about what these accolades are attached to? What technology, what treatment, what innovation?
Yeah, very happy to. And you quite rightly use the word accolade, because I think that, I've read somewhere that when a startup gets its technology and it's recognized at sort of national level, international level, and conferences like this, you've sort of, in inverted commas, made it. So the accolade is definitely for Vlad, but it's also for the team here, who in the space of 7 years, we've developed a completely different approach to the delivery of reagents on site, as opposed to having them made in large factories, and they're produced on site and on demand. Whether that's for treating arsenic or for chrome, that's the major sort of, if you like, advance in the technology that we're bringing to AWWA, and it's great to be in the spotlight at last.
Yeah, at last. And so both of these accolades are around the SafeGuard H2O technology that generates a stannous and a ferrous reagent, non-toxic versions of them on site and on demand. But given the broad applicability of those two reagents, it's not just around arsenic removal and hexavalent chrome. So where is AMS focusing efforts on bringing those reagents and the treatment and the SafeGuard H2O to market?
So primary focus, as you say, is chrome, which is now regulated contaminant here in California, impacting 5 million people. And the paper will be talking about how cost effective versus traditional legacy technologies that are being promoted is arsenic, but also stannous is again, this is all in the literature, we didn't invent the chemistry, is a very effective anti-corrosion agent and also a germicide, bactericide. So in applications like produced water treatment, it can remove hydrogen sulfide and the bacteria that generate it much more effectively than alternative technologies. So we're working in the oil fields of Texas to treat frack water so that it can be reused for agriculture or reused for fracking. So multiple applications.
Oh, that's just so exciting. That's really exciting, Rick. So it's not just stannous and ferrous, though, because my understanding, and I guess anyone really who's familiar with AMS knows that transformative innovation is somewhat paramount with what you do. So you've proven the efficacy of the on-site generation of stannous and ferrous, but most recently, AMS has also been moving forward with the on-site generation of ferrate 6, which is a really powerful oxidizer, the most powerful one out there. And you're generating it on-site and on demand. And ferrate has the really broad applicability to such a wide range of not just regulated, but emerging contaminants. So tell me a little bit more about how you're bringing the power of ferrate to the water treatment and industrial markets.
So yeah, I mean, ferrate is an incredible chemistry. Again, though, it's very well documented, lots of research done. The problem has always been, how do you move from lab, bench, scale, research, all that good stuff, to industrialized volumes of production? And that's what we've mastered by it's got a very short shelf life, so you can't make it in a factory, you have to make it on site. And we can make it on site and on demand. And so multiple applications, PFAS, azoles, which is a major contaminant in semiconductor plants, ammonia, which is problematic in semiconductors, drinking water, wastewater, microplastics, phosphate, the list goes on. But it's not only the chemistry that we've sort of mastered of this, but also how we get it to the market. So rather than being sort of bound by the number of people we have here being able to go out and do demonstrations, we've discovered in the case of ferret, we can freeze it and then send it to anywhere in the world that wants to, literally, who wants to try this chemistry at home in their particular application and understand what it can achieve and can deliver. And then we can follow behind that with the sort of the hardware itself. But at least this gets the chemistry out there far faster than our sort of limited resources would enable.
Yes, and speaking of the limited resources and this frozen ferret, it makes me want to just ask, to enlighten our viewers a little bit, what is the process of working with AMS to put any of these stannous, ferrous, ferrate, and generating them on site and demonstrating them? What does that look like for a municipality or an industrial facility?
Well, you're right to refer to it as a process because part of our drive has been getting product to market as quickly as possible. And that's a problem for the industry. So we've got a very tight process, which begins with what we call go, no go. So send us a sample of whatever you're worried about, concerned about, and we will determine very quickly here in Sunnyvale or in College Station, Texas, whether we can treat that technology to the real contaminant as opposed to some synthetic version of it. And if that works, we can then go to deployment of hardware in the field to demonstrate its effectiveness. So that's how we work. And it's a very tight timeline. We don't want to waste people's time and attention. It's getting to market as quickly as we can and getting people to see what this technology can do.
So you have the versatility to bring your products to market, and then there's also the wide range of products and solutions that you have. So I'm starting to understand why AMS is referred to as the Swiss Army knife of water treatment. What does that mean to you, though, in the context of what AMS does? Could you share with our viewers a little bit more about that?
Sure. So the Swiss Army knife, you could use a single blade, which could be a client who has got a treatment system that wants to run it much more cost effectively and make sure they're in compliance, so they get just the blade. Another opportunity is where we've delivered a treatment system which is integrated with our real-time monitoring, so we can offer the single solution if you wish, but also a fully integrated solution of treatment plus the monitoring, which makes the whole system much more automated, underpinned reliability and performance, and sets us apart from many other much larger companies in the industry.
Oh, absolutely. And in addition to that, I mean, the perspective of whether or not you're integrating your monitors with your treatment solution, those real-time water quality monitors are also standalone solutions that can be integrated with other treatment technologies, allowing facilities to have a greater visibility, ensure compliance, and also reduce the cost of compliance, whether that comes about from process optimization, automation, et cetera. So that is it's a good motto. It's a good motto to have. Um, so I just want to thank you, Rick, for your time today, sharing these insights. And I really hope that Denver is ready for what AMS is going to be bringing to ACE 2025 this year. And for any of our viewers who will be attending the conference, I encourage you to stop by the AMS booth, 12:30. You can speak with Rick or any of the other team members about the transformative power of AMS and their advanced water treatment and real-time monitoring solutions. So thanks again for being here, Rick.
Thanks you very much indeed. Great to talk to you again.